So I would like to start very broadly and also about something where I'm not an expert in, so I hope I can just quickly go through this. But when you think about human physiology, human physical characteristics, we are quite a peculiar species. So for example, our canine teeth, compared to many other animals and also our closest relatives, is quite small. So we are not as dangerous as, for example, chimpanzees in this regard. Our digestive system is also quite bad compared to a lot of mammals. So our colons are rather small and not so long. So we are really bad at digesting raw food. And lastly, also when you look at our muscle strengths compared to many other animals, we are not as strong. And for example, we don't have as much fast twitch fibers compared to, for example, monkeys, apes. So that means we are kind of okay at long distance running, but we are not very strong in a fight against a chimpanzee or an orangutan. So in a way, we are, as a species, not very dangerous from a first look. We are not very good at eating raw food and so on and so forth. And what that sums up to, at least that is one idea that came up, is that from the outset, from our physiological and physical markup, we are highly socially interdependent. So we need others to hunt, we need to cook our food, which takes also a lot of cultural practices, and we are not as strong on our own. So at least from our starting position, you would assume that we are a species that highly relies on cooperation. Now, sustaining cooperation can be tough. So for example, if you model cooperation as a public goods dilemma, as probably most of you are very familiar with, you are ending up in a social dilemma. Because if others do not cooperate, then you should not cooperate yourself. And because of the cost-benefit structure of cooperation in such an environment, if others cooperate, it's still even better not to cooperate, because then you can free ride on the others' cooperation, right? So we know that this is a very, very tough environment to sustain cooperation in groups. And basically, we need a lot of additional institutions, peer punishment, reputation, and so on to keep cooperation going here. An environment that is a little bit easier to sustain cooperation are, for example, situations that are modeled like a collective risk dilemma, which is basically a variant of a step-level public goods game, where the idea is that the group has a shared goal or shared threat, and they have to accumulate enough, they have to contribute enough resources, they have to reach a certain step level in order to prevent something bad from happening or something good from getting realized. So in this environment, at least even if we assume selfish preferences and rational play, you have equilibria that are where everyone is cooperating. But now, when groups face these shared problems, sometimes they can be self-reliant. Sometimes there are individual solutions to these shared problems. And I would argue, especially in modern societies, we do have these shared problems, these shared needs, and there are collective solutions to these needs or problems. But then also what is sometimes provided are individual solutions to shared problems. So as an example, we have public transportation system, public schooling, publicly funded police force, public parks, right? So a lot of things that we would characterize as public goods that require cooperation, that require contributions from individual group members. At the same time, we ran into this problem of cooperation. There could be free rider problems and coordination issues. But at the same time, at least to some degree, and that also differs between societies, we also have private solutions, like private transportation by car, private schooling, personal security, gun ownership, private gardens, and so on. So for example, currently in Germany, there's this huge discussion between how to allocate funds. Should we fix the German Bahn, or should we put more money into the Individualverkehr, right? So on on Autobahn and so on. So these private solutions you can see also as a remedy to the free rider problem. If you can do something on your own, if you don't need other group members, of course there's not the free rider problem. You don't have to coordinate actions and so on. So in a way, there's also a dilemma inherent in this. Should you solve a problem on your own, or should you coordinate with the group? And that is what we wanted to capture in an economic game, which we call the private-public goods game. And here the idea is that a group of agents is confronted with a shared problem, and they have resources, and these resources they can invest towards solving this problem. And first of all, there is a cooperative solution where they all invest into a cooperative solution, but there's also a self-reliance solution. So to illustrate this game, I just want to use a small metaphor. So imagine a group of villagers that is faced with a flood. And one solution they have towards this danger is they could work together and build a dam around the whole village. And if they make it in time, then all of the villagers are safe, and if not, they lose all of their wealth or well-being. But then the idea is there's an alternative way to solve this problem, and that is to solve it individually. So imagine a villager can also just build a dam around his or her own house, and if finished in time, then this villager is saved, but not the other group members, right? So that is what, in this context, we call self-reliance. With a threshold, with a private threshold CI, so that is the cost of the individual solution, and then there's the public threshold CP. CP, which is the cost of solving the problem as a group. And then, of course, with the collective solution, there's also the free rider option, where you just keep your resources in the hope that the others will solve the problem for you. And just to illustrate, so we invited people to the laboratory and wanted to see how they solve this dilemma between private-public solution. And to illustrate this game, I just want to show you how some groups behaved in the laboratory. So what I will show you are some participants and how, based on this metaphor of building a dam, how they allocated their resources across the 10 rounds of the experiment. Now I will have to coordinate it a little bit because I want to stop it, but here, you can see that in this group, a lot of group members went for their collective solution. Now I have to manually stop it. So here is an example of a group that built the dam around the whole village. They cooperated, they coordinated their actions. But if you look closely, the colors indicate by which group members the resources came from. And that's probably hard to see, but maybe you can see that only 3 colors are represented. Actually, the blue group member in this group did not contribute anything to the collective solution. So that is just the classic free rider dilemma, right? So the blue group member was perfectly well off, keeping all of his or her resources and benefiting from the collective solution. But at least in the end, they solved the problem. So here, let me go to the next. Here you can see another group where first they went for the collective solution. So they invested into the public pool, but then red and blue started to work on the self-reliance solution. And in the end, sorry, let me just quickly. So red and blue went for the individual solution. And in the end, they did not manage to solve it collectively. Right, so here you see an example of kind of coordination failure. So 2 group members were saved going for the individual solution. 2 group members in this experiment lost all of their money because in the end they did not finish the public solution. Yeah.
Is the individual solution equally effective?
I will come to that in a second. Yeah, indeed. That is one thing we manipulated. So right now I just show you some group dynamics just to give you an idea of what can happen in this situation. So here my last example, here you can see how 3 group members from the start actually worked on their individual solution. One group member really wants to get a collective solution, a group solution, but nobody is chipping in. And at some point, of course, this contribution becomes merely symbolic because, I mean, the blue group member realizes that he or she cannot solve it on their own anymore. There are not enough resources available. So maybe it's just to make the others feel bad that there's such a lack of social support. But indeed, what we did in this first study was we manipulated the relative cost of the individual solution to the collective solution. So basically, what we did is each group member had 100 resource points worth money to them. And across blocks, we varied the cost of the individual solution. So the public solution was fixed to 160 units. So that means if each group member would contribute 40, they would reach a collective solution and a very fair one, right? So then everybody contributes 40, the group is fine, everybody is equally off, and so on. Now, across the blocks that we counterbalanced, we manipulated the cost of the individual solution between 80, 70, 60, 50, and 40. And then you can calculate kind of a ratio of these cost levels where you take the cost of the individual solution divided by the fair share from the collective solution. For example, when the cost level is 40, then, well, you can solve it as equally well compared to the collective solution given a fair solution. So here it makes sense, why would you go for cooperation, right? So why would you bother? So, and that is indeed what we saw, maybe not surprisingly. So the lower the cost of the individual solution, the more people, of course, started to say, okay, I'm out of the group, I just do it by my own. So you see this crowding out of cooperation based on the cost level. So that is not so surprising. What was a little bit surprising to us was how quickly people opted for just rather solving it on their own, right? So already when the collective solution would be, in theory, more efficient, people started to rather solve it individually. And another thing that happened was that we observed this inverted U-shape relationship to coordination inefficiency. So here we just calculate how much resources they spent in this game over and beyond the most efficient solution of just investing 160 units to the public solution. And here what you see is that, especially in this between cost levels, there's just a lot of wasted resources. And that is basically that groups start to get into a coordination conflict, right? So some go for the individual solution, some go for the public solution. There's no strong preferences. And then they're just miscoordinated. They waste a lot of resources. Yeah?
Is that they see dynamically what the others are doing?
Yeah.
So after each step, and then they can shift.
Yeah. So in this first study, it was exactly, it was not kind of a reset. It was really a dynamic game where they had 10 rounds. In each round, they could invest up to 10 units. And then you would really see what other people would do. A little bit like in the animation, right? So you could kind of see how the dams were built. Yeah. So especially given these coordination costs, we thought in this first study, okay, what about introducing some institutions that might help in this problem? And we thought, okay, let's try peer punishment. Because as you all know, I mean, peer punishment has been used extensively in the public goods game, and under normal circumstances, taking aside antisocial punishment, counter punishment, and so on, can work quite well in getting rid of the free rider problem, so this conflict between free riding and cooperation. So we wanted to see what it does to this conflict, not only between free riding and cooperation, but also self-reliance. So in one treatment, we added a peer punishment stage, 1 to 3 mechanism. After every round, they could punish each other and wanted to see what that does to their behavior. So here you can see what we did here is we categorized people based on their final investment profile. So over-cooperative are people defined as contributing more than 40 to this public solution, so more than your fair share. Free riding we define in this context as cooperating less than 40 and also not going for your individual solution. Cooperating means you exactly contribute 40, so the fair share to the collective solution. And individualistic, we call people who just did not contribute a lot to the public solution, but managed to reach the individual threshold. And this is kind of the distribution of types, if you will, in our control treatment without peer punishment. And now when we introduced peer punishment, what happened was that individualistic choices went down and people cooperating went up. So it did increase more of a communal coordinated action. The interesting thing was that the degree of free riding did not change a lot in this setting. And when we looked at the punishment pattern, it also made sense. So here you can see who punished whom, and I deleted the numbers for now, so it's just the thickness of the arrow shows you a little bit the degree of punishment, and then above the free riding types, the left the individualistic, and right the over cooperatives that we call here. And there was some punishment between all of these types, some punishment towards free riders, but the interesting thing is that the most punishment was used by those who were cooperating more than their fair share towards those that went for the individual solution. So people who, revealing by their behavior, seem to prefer a collective solution, they punished those that went for their own solution. But interestingly, the people who went for self-reliance were also willing to counter-punish those that went for the collective solution. So it was kind of a punishment feud between kind of the collectivist and the people who rather went for the individual solution. And in this punishment, they also, again, lost a lot of resources, of course. Now, in the second study, with this game, we wanted to see what actually inequality does to this self-reliance and cooperation. Yeah, sorry.
Great question. Was it in some sense also efficient to do this punishment, in the sense that you would basically change behavior of people in education?
Yes. I think we could not. Yeah, it's a little bit, you need a counterfactual, right? So what if they would have chosen? But indeed, I think one logic behind these results is, so who are you going to punish? The people who do not invest at all, or the people who are willing to invest resources, but in your view, go for the wrong solution concept, right? So in that sense, it probably makes sense for these cooperators to target individualists, because then it's just a signal, hey, it's nice that you are willing to invest resources, but please don't do it in your own pool, but do it for the collective. Yeah, indeed. Okay, so in the next study, we also thought about, okay, so especially with these private solutions to shared problems, what if some people cannot afford that, right? So maybe some people cannot afford a car and are more reliant on collective cooperation and so on. So maybe some people depend more on the group than others. So how does inequality influence self-reliance in this situation? So again, we used this private public goods game, and here we had 4 group members in the lab in the symmetry condition where everybody had the same amount of resources at the start of the game. And in the asymmetry condition, we had 2 rather poor group members who started with less endowment, and 2 kind of rich group members that had more endowment. And that also meant across the cost levels of the individual solution, it was relatively more affordable for the wealthy participants to, of course, solve the problem on his or her own, And in some cases, it was only possible for the wealthy participants to solve the problem. And we had a little bit of a different cost structure here, but that doesn't matter so much. Basically, from left to right, you again have a decrease in the cost of self-reliance, so it becomes more and more affordable. The infinity symbol actually indicates one block where there was no individual solution, so the game just reduced to a simple kind of step-level public goods game. And here what is shown on the y-axis is how often wealthy group members did not contribute at all to the public solution. And the more affordable self-reliance became, the higher the likelihood that especially wealthy participants opted out of the problem. So they just solved it on their own, they left the group and so on. Now, when we look at what that means to earnings, here you can see how much rather poor group members and rich group members earned as a percentage of their starting endowment. And the interesting thing is that when there was no individual solution or private solution, so when they really were forced to solve it as a group, then the public good actually served as a redistribution device. Not significantly so, but descriptively, rather poor group members earned more as a percentage of their starting endowment compared to wealthy group members. But then when we introduced individual solutions and lowered the cost of that, that changed. So basically what happened was that the difference in earnings increased, meaning that the lower the cost of the individual solution, the more wealthy group members actually benefited from that. And the less and less poor group members earned as a percentage of their starting endowment. And also across groups, across rounds, we saw kind of a pattern where, in this case, rather wealthy participants took advantage of their position. So the ability to kind of solve the problem on their own, kind of exit the group, and thereby force on the others that they have to kind of solve it on their own. So specifically, the less poor group members cooperated in T-1, in round T-1, the more wealthy group members opted for self-reliance. And the more wealthy group members opted for self-reliance in round T0, the more poor group members cooperated in T+1. Right? So the idea is that to some degree, high endowment group members use self-reliance as a coercion device, right? So over rounds, they can say, if you as a poor group member do not cooperate enough, I will opt for self-reliance in the next round. And then that forces kind of the poor group members to start cooperating more. And then that increases the chances that the rich group members enter the group again. So in a way, they have, of course, a more powerful position here. In the study, because of these inequalities that also result after the end of the game, we also were interested in how third parties would solve this problem. So what we also did is we invited some people to the lab. We explained the situation to them. And we asked them, okay, if you would be able to distribute all the resources from all the group members, how would you solve this problem? How would you allocate for each group member their resources, and so on and so forth. And then in the actual experiment, we asked groups, hey, we asked each individual group member, would you like to delegate one round to this third party? So should we replace one of the rounds you played with actually how the third party decided? And interestingly, they did not know specifically how the third party allocated the resources. So they were just asked, do you want to have kind of a third party making decisions for you as a group? And what we saw was that a majority, so over 50% of group members with a lower endowment were in favor of delegating to this third party, whereas a minority, so below 50%, of the wealthy group members were in favor of delegating. And when you looked at how third parties decided, it also made sense kind of from a selfish perspective, because when we look at the difference between how third parties decided, how groups actually decided, and then looked at the change in earnings, then third parties favored a communal solution, like a coordinated, a cooperative solution. And they rather preferred a solution where rich group members were investing a little bit more relatively to poor group members. So actually, poor group members would have benefited in their earnings when delegating, whereas wealthy group members would have lost a little bit of their endowment. So it seems like even though they did not know how third parties decided, they voted in a self-serving manner, or at least it is consistent with the ideas that they did so. Now, lastly, also when we talk about this self-reliance and maybe a little bit kind of in our society, the idea is that we often also restrict access to these individual solutions, right? If you think about gun control, if you think about taxes on car emissions and so on, right? So in some cases, and it's also things where societies differ a lot, we restrict access to these individual solutions, and we enforce kind of public solutions, public goods, and so on. So in the last study, we wanted to see, in this public-private goods game, we wanted to see if actually endogenously groups would be willing to restrict access to these individual solutions through a simple voting mechanism. So here we had groups of 5, and basically for the next 3 rounds, they could vote whether they want to abolish individual solutions. They were forcing the group to cooperate, also inviting the free rider problem, inviting the issue of miscoordination, or they could vote for keeping the individual solution. So based on a simple majority principle, that is also why we invited groups of 5 here to always have a clear outcome. They could, in one condition, basically endogenously choose to restrict access to individual solutions. And the interesting thing is that they really did in a lot of cases. So here you can again see it based on the cost-benefit level, but the basic picture is that most of our groups over the rounds voted in favor of restricting access to individual solutions. They were really forcing themselves to solve it as a group. But also here we introduced inequality. So we had one condition where there were 3 rather poor group members and 2 wealthy group members. And here you can see their voting pattern. And here again, we see a main effect over the cost, the relative cost of the individual solution. So the more affordable solving the problem on their own, the less support for restricting access. But you also see a main effect between low endowment and high endowment participants in the sense that rather poor individuals in our groups were more in favor of restricting than more wealthy individuals, which of course also makes sense given the data I showed you about using this mechanism to also get a kind of a strategic advantage, right? So to summarize, when thinking about going from self-reliance to really working as a group, creating solutions for the group, creating kind of club goods that solve a problem for the group, the idea is that what helps is higher interdependence, so high cost of self-reliance in this case, voluntary restrictions on self-reliance, letting third parties decide is also helpful, and it helps when there is equality. So when you cannot take advantage of your position because it is, for you, it is more affordable to solve the problem on their own compared to the others. But now I actually would like to go one step further. And yeah, oh, I see my time here. Yeah, okay. I have to quickly go one step further. Now I want to actually go to the idea that, okay, so that is how to go from self-reliance to cooperation, to creating club goods within groups. But a lot of problems, especially in our times, are not only problems for groups, but also cross groups. So if you think about climate change, pandemics, and so on, that is not a problem anymore for singular groups, but it affects also across groups, across group boundaries, and so on. So now I want to take the last minutes to talk a little bit about intergroup cooperation. And I think in the last decades, we made quite some progress in understanding cooperation. So we have very, very good fundamental principles of how cooperation can develop. Like indirect fitness can explain us, indirect fitness theory can explain us how cooperation among close kin can develop. Direct reciprocity, I help you, you help me, can explain very powerfully how cooperation in diets can come about, how friendships develop, and so on. And then indirect reciprocity, when we talk about partner choice, reputation, and so on, we can even go beyond diets and explain cooperation in groups. And then if you go one step further, talk about generalized reciprocity, social norms more broadly, we can also explain how cooperation develop in larger collectives. Yeah. But the question now is, okay, that are very powerful mechanisms to explain when and why cooperation develops. But then how can actually cooperation develop beyond group boundaries? So not only within groups, but really beyond groups. So in a way, how can cooperation develop beyond club goods? And for that, we did one study where we used a nested dilemma structure, or also called multi-level public goods game, where the idea is that in this case, you have two groups, and the groups are characterized by having their own club good. And then there's also public good. And the idea is that each individual group member can either go for club good cooperation, so paying a cost to create a benefit for every member of the group only. So therefore, it's a club good, it's excludable, and so on. Or alternatively, an agent, a decision maker can go for public good cooperation, creating a benefit for everyone, regardless of their group membership. And here, in both cases, the marginal benefit for the individual is smaller than the cost. So whatever you do, free riding, not investing at all, neither towards the club good of your group or towards the public good, is better than just keeping your resources. So just to illustrate, so here are the expected payoffs of different strategies: public good cooperator, club good cooperator, free rider. It's not so important, so it's just the expected payoff from the public good and from the club good. The important thing is that by definition, each of these types get, of course, the same return from the public good and the same return from their group's club good by definition. But the cooperator, whether it's a public good cooperator or club good cooperator, they have to pay the cost of cooperation, right? So that is just to illustrate easily that free riding should be dominant here, right? So free riding should be the best strategy. So we need something beyond this public good setting to keep cooperation going. And what we do here is we introduce a second stage that has been done also in a lot of other studies before, where we introduce kind of a dyadic helping game. And the idea here is that one person from the population meets another person, and then you play a dyadic helping game where, based conditional on the decisions of stage one, this agent can then decide to pay another cost to create a benefit for the receiving agent. And now what we thought here is that, well, but who you're going to meet might depend on group characteristics. So for example, maybe belonging to a group means that it restricts your who you're going to meet in these dyadic interactions, right? So if group boundaries are very solid, that means maybe you only interact within your group, so you only meet in-group members. Whereas group boundaries can also be a little bit more fluid, and in the most extreme case, maybe groups are not so restrictive, and therefore you meet also a lot of out-group members. So basically, that is what we try to formalize with this parameter p, where if p is equal 1, you only meet in-group members in this stage 2, and where p is equal 0.5, you meet out-group members as often as in-group members. And that changes the expected payoff, where if we assume a certain combination of strategies, for example, public good cooperators help other public good cooperators independent of their group membership, where club good cooperators help other club good cooperators of their own group, then you get some expected payoff from these dyadic helping interactions, and these can basically compensate for the cost of cooperation in stage 1. So I try to be a little bit faster because I see I'm running out of time. But basically stage 2 in the setting is our cooperation engine. And it has 2 components. The one is the helping benefit, so how worthwhile is helping to the other person. And the other is this P, the likelihood to meet outsiders. This is what we also call group fluidity. And then what we did is we did some numerical simulations to see what type of strategies would survive in the long run in such a setup. So for that, we used a frequency-dependent Moran process. And I won't go into the details, but basically, we wanted to see what is the stable, long-term, steady state in such an environment based on a very simplified evolutionary learning mechanism, the Moran process, based on 3 types of strategies. The free rider strategy, not cooperating in stage 1, not helping in stage 2, of course. And then the club good cooperator is cooperating towards the club good, so helping the group. And then we assume in stage 2, this agent would help other club good cooperators from their own group. And then the public good cooperator is provides for the public good, and then is helping other public good cooperators in stage 2, regardless of their group membership. And here you can see what is the result from these numerical simulations based on the 2 parameters that we are interested in. The one is the group fluidity, and the other on the y-axis is the helping benefit. And here is the degree of free riding you can observe in the population. And the simple idea here is that if the helping benefit from stage 2 is not sufficiently high enough, then free riding is just dominating. But as soon as helping can kind of outperform the cost of cooperation in stage 1, then free riding disappears. But what type of cooperation appears depends on P, on this group fluidity. So if groups rather stay within their group, do not meet outsiders, also, right? We also talked about the contact hypothesis. Then what we see is rather club good cooperation. But as soon as group boundaries become more fluid, then universal cooperation can emerge. And one interesting thing is that if you look at a low helping benefit, then you also have some nonlinearities here in the sense that with a low helping benefit, having solid group boundaries at least gives you some parochial club good cooperation, whereas as soon as boundaries become more fluid, free riding is dominating. Whereas in higher areas of helping benefit, you just see the switch from club good cooperation to universal cooperation. So lastly, we wanted to test this experimentally. So we invited groups of people, 4 participants and 2 groups, and they exactly played this game. In stage 1, they made a trinity choice where they had to decide, do they want to keep their unit, try to free ride, go for club good cooperation, MPCR of 0.5, or public good cooperation, here an MPCR of 0.375. Yeah. So that was the nested dilemma, stage 1. And then in stage 2, they would be paired to another participant. They learn about their group membership. They learn about stage 1 decisions, so what did they do in stage 1. We also gave them second-order reputation information, so for stage 2 from previous rounds. And then as a helper, you decide, do you want to keep your additional units, so no help, no cost, or do you want to help the receiver for a benefit of 3 and a cost of 1? And then this was repeated for 20 rounds, so always stage 1, stage 2, stage 1, stage 2, and so on. And then what we manipulated was, of course, this P. So in these solid boundary conditions, participants only met other participants from their own group. And with the fluid boundary condition, it was basically random, right? So you would meet out-group members as often as in-group members. And then very quickly, for free riding, it increased a little bit over rounds, but did not change a lot. No difference between conditions also, as we would expect. But then for club good cooperation, we saw that it was higher when group boundaries were solid, and for public good cooperation, it was exactly the opposite. So qualitatively, what we expected based on our model. Quantitatively, it was interesting. If you look at the rank order, there was still more universal public good cooperation in the boundary condition compared to the others. And that had basically to do with social preferences. So regardless of condition, people with social preference were just more in favor of public good cooperation. But in general, when we looked at the helping pattern, we did see why that made sense. And for the sake of time, I will quickly go over that. So basically, the gist of that is that in the fluid boundary condition, there was a higher likelihood that you received help when you contributed to the public good compared to the club good. So also from a selfish perspective, it made sense in the fluid boundary condition to start cooperating more universally towards the public good, because you were more likely receiving help from others. And also, after the experiment, we asked participants how they identified in a simple questionnaire. And we asked them how much they identify with their own group of 4 people, and how much they identify with the larger collective. And what we saw was that in the solid boundary condition, identification towards the group or the larger collective was basically 0, the difference. But then in the fluid boundary conditions, that shifted. So all of a sudden, people started to identify more with the larger collective than with their own group. So in a way, kind of an indication of psychological group fusion. And now for the sake of time, I will skip some simulations that we did, and we'll just move to the conclusion. So in this case, what we try to show is that group boundaries may influence the reach of indirect reciprocity. So a very, very fundamental mechanism to sustain cooperation in general through this meeting probability. So basically, when group boundaries are solid, indirect reciprocity favors group-bound cooperation, club good cooperation. And when group boundaries are more fluid, then indirect reciprocity favors group-transcending public good cooperation. And then also frequent intergroup interactions may lead to something like group fusion. So you also start to identify with the larger collective. And then, we also looked at larger groups and so on. But to summarize, the idea is that, well, with interdependence, you can move from individual problem solving to cooperation. But then you might create club goods. But in some situations, you might need to create public goods, so really that encompass groups. And here, also in line with intergroup contact theory and so on, higher intergroup contact might actually get you to this higher order public good cooperation, and even maybe in some degree to something like group fusion. So all of a sudden, groups merge and create larger entities. So thank you very much for your attention.